back to another fancy episode of Hand Tool Rescue. Today we have a Craftsman Model 109 metal lathe. This was a pattern maker's lathe or a model maker's lathe. Nothing heavy duty, but just enough to get the job done. And by just enough, I really do mean just enough, as you'll see in the rest of this video. Right here are the gear assemblies. You can use these to actually do threading on this lathe. If you configure these in different directions and different positions, you'll get a different thread out of it. I believe I'm missing one gear that would make this gear set complete, so it does limit the number of threads that you could potentially cut with this lathe, but I guess you could make another gear with the set number of teeth, or you can just find one online. I'm sure it does exist. In this case, it wasn't really worth trying to find that gear because apparently they're like $100 a gear, which is insane. You could get it machined almost close to that if they know what they're doing. So that's really what I'm taking apart here, is just kind of get every possible section of the gearing off, and then I don't have to worry about it. They are made of zinc, or at least a zinc alloy, so I'm not going to be putting them in the evaporust just in case. I know it doesn't really react with zinc like it does with magnesium or cadmium, but just in case the alloy does contain some of those metals that you can't put into evaporust, I'm just going to clean them up with either sandblasting or just wire wheeling and filing to get any massive burrs or any damage off any of the teeth, just so it sounds a little better, because you never know exactly what has been damaged. This part here is still that zinc alloy, so I'm trying to be as gentle as I can to some respect. There's a burr on the end of this that was stopping it from coming off, but I don't know how strong that alloy is. Just by reading online, apparently people didn't really like this specific alloy because it broke very easily. I guess it was very brittle. But to me, you know, all of the teeth are here, and that's nice to see. It's not as common, and it's better than plastic gears, I would assume. So, you know, it's not the end of the world. But for metal lathe purposes, it's maybe not ideal. The tailstock, which I'm working on right here, was a very simple design. It's just clamped down with one bolt. It's not that exciting. You can see to the right of the lathe, the farmost part of the bed, they've actually cut out, the previous owner at some point cut out a section. Here it is again on the left, just to extend the range of the tailstock, I guess. I guess they were doing something longer than the capacity, the original capacity of the lathe, so they decided to expand upon it. I'm not going to fix that in any way. I'm just going to kind of leave it. It'll be hidden by the tailstock anyways, which in case of this tool, maybe won't even get used very often, for my purposes at least. The handles are once again that odd zinc alloy. So I'm just trying to be gentle, take it easy. No need to smash things, although it is fun. Now on to the cross slide. This is another simpler version of, you know, a normal cross side. You have your lantern tool post right here that I'm taking apart. Comes with a fancy, maybe high-speed steel cutter. And then the rest of it is just all usual cross slide stuff. Rather, you know, other than the nail that is used here to hold this handle on. Unfortunately, this lathe doesn't have any sort of dial indicator on anything. There aren't graduations on anything, so you don't really know how far you've gone in terms of making a cut. You just have to either use your own indicators or it's just a lathe for general stuff, or you just use calipers as you go along. It's not exactly, like I've said before, the most precise lathe in the world. This screw here is oddly, it's just pinned in and then pinned over, and then it can never come out because there's no room for the pin to come out on the other side because there's cast iron in the way. So things like that pop up during this lathe where it clearly wasn't designed to be as fully repaired as I'm trying to go here. It was just meant to do the job that needed to be done. These nuts, these lock nuts, are clearly deformed and will need to be fixed or replaced. And it looks like if you can bend them that easily, they probably need to be made a little thicker, a little stronger, maybe out of better hardened steel. I'm not exactly sure. Yes, you want those to give and not the cast iron around it, but it's not the most ideal design, clearly. The thing I'm unscrewing right now, you could see there's like a little metal foot underneath, and that grabs in under the V-ways and keeps the cross slide supposedly from jiggling up and down like I'm doing right now. The only other part that's doing that is that piece of cast iron that slides along the back. It's just not that rigid. This is when a giant, and by giant I mean tiny, ball rapidly shot at my face. So I'm glad that it didn't hit my eye because I wasn't really wearing glasses. And I should have expected that, but I guess you just get caught up in the moment and don't realize that that mechanism works by ball and spring. This was another way that they locked the nut in, and it was just punching the end of the screw, and then that would widen it, so you couldn't technically unscrew it very easily. You know, not the most majestic way of locking a nut in place, I would think. Now onto this little wheel here. This is the hand wheel. This thing drove me insane. I could not get it off. In the video here, it's fairly quick, but obviously off camera, this took me hours to figure out. Like, literally hours. It would spin. It's clearly not locked in. I couldn't see what was going on. Why wouldn't it even move just a little bit? Like, how is this possible? I tried heat. I tried all this acid. I tried all this stuff. Nothing really worked until I decided to punch it out, risking that I break that smaller zinc casting right behind it, knowing that that would be something that could be fixed easier than this wheel, which needed to be replaced anyways due to it clearly being warped. So I just continued to punch it. It wasn't crazy hard. It scares me punching things through other things. Castings don't really like to flex that much, so you got to be careful when you do something like that. But it did reveal finally what the issue was, and you could see right there the set screw completely ate into the lead screw here. So that's odd to me that it wouldn't have, something that moves the cross slide left and right that you'd use fairly often wouldn't just be a flat on the end and the set screw hits the flat like every other set screw in existence. Seems like a very poor design, if you ask me. So I'm taking off the whole spindle area now, and I probably should have just taken the chuck off at this point, but I did not. This little pin right here engages the back gear, and that's that drum that you see next to the pulleys. It engages it or disengages it depending on how you need it. You push the pin in and out, and it kind of locks in position. Regardless, that's the weird screw that you can move around if you want to engage or not engage the pin. So there's some kind of adjustment there as well. And then I do my usual bushing check to see if it's a disaster. And these weren't too bad. And even if they were, this isn't a big deal as much as the spindle itself being the spindle bushings themselves being an issue. These are clearly insanely worn, so I will just have to replace those to the best that I can. These are a disaster because they always fly in your face and try to kill you. Exactly like that. We don't really need that because I kind of like being alive at this point. So always watch out with those circlips. They're going to get you. Here, that right there is the bushing, the adjustable bushing, and you'll see me deal with that later when we reassemble. It's a neat design in that as you tighten the bushing with the nut on the other side, it will clamp down tighter and tighter to adjust for any wear. It's a neat idea, and it is nice to get the chuck off. You can see there's a dead center in the middle, and that means that this entire spindle shaft is hollow, which is, in my respects, not an ideal spindle design. It's also only half an inch, so it's a very weak spindle. If you even tried to take a heavy cut, you'd probably bend the whole thing, which you don't want to do. So there are people online that have been modifying these just to quickly modify to improve on the design here, at least for strength and stability and accuracy. And one of the things is to make the spindle solid instead of hollow and just getting rid of the Morse Zero taper that goes into this specific lathe spindle. It's not worth it. I guess you could try and cut one into a solid spindle, but it's not likely that you could pull that off very easily. It's a very tiny thing. The Evaporat's doing this job. I took a little bit of different approach this time, and I did just soak the pieces before I removed the paint, just because I wanted to see the original paint. As I was taking it apart, it didn't look horrendous, but with all this paint splatter, it's not worth it. Here you can see the bushing is out. At least the other bushing, not the adjustable one, but the other spindle bushing is worn too much, way too much. If you can see it, it's too much. So that's going to need to be completely replaced and machined to spec based on the wear in the actual spindle itself. Back to the paint. I decided it's got to go. These specs are obviously not ideal, so we're going to get rid of these and hope for the best. This part, for some reason, is aluminum. I don't know why. No other castings are. It's got to be just because of how it's attached. If this was cast iron, it would bend the way it was attached. Here we have my brand new sandblaster. It is much better. I had to run it without the vacuum on so you could hear. I don't know why I wanted you to hear this, but just enjoy that. I'm excited that I can use larger items inside of a sandblaster. That should come in handy for some upcoming projects. Here I'm using my usual trick of using just really cheap earplugs to plug the holes. I don't have time to deal with plugging those up in any other way. The same with this. I just put a layer of paste wax on stuff I don't want to mask off with paint or with tape, because I absolutely hate that. So that's my little trick for that kind of stuff. It just scrapes off very easily because obviously the paint's not going to stick very well to the wax. Very simply, I did coats of self-etching primer as usual, and then 4 coats of this was Tremclad, which is Canadian Rust-Oleum, just gray. Oddly enough, it had enough of that blue in it that I was looking for to match the original color here. A lot of the other grays were just not gray enough, if that makes any sense. I finally, after derusting, got the chuck to move, which is incredibly rewarding, and it does actually still run fairly smoothly. All I did to this was kept oiling it and spinning it and oiling it and spinning it, and that seemed to make it incredibly nice to use. So instead of taking it all apart, it's just gonna kind of stay like that. I don't want to get in there and do something. I've taken them apart in the other jeweler's lathe restoration, so I'm just going to take it easy on this one. Also, the large wire wheel is missing, and that's because it attacked me and flew off the drill press. This was unnecessarily taped off. I don't know why I would do that. It seems like a waste of tape. Here you can see the paint just easily scrape, like I'm barely even pushing this chisel. And if the chisel wasn't part of my shit chisels, and it was actually having a flat edge, it'd probably be even easier to get that stuff off. So all of the machined flat surfaces I hit with my coarse diamond stone just to get the high areas down and equal to the lower areas. I just thought, it can't hurt. You're not going to be taking off that much material anyways, and you might as well have very nice surfaces. Not that they're, square or parallel to each other. It's just nice to have surfaces that mate perfectly. And the paint, I think, came out very well. I waited, of course, like a week. The 24-hour to 48-hour rule on the can is ridiculous to me. It's nowhere close to hard at that stage, at least in my workshop. Maybe if it was hotter, it'd be a little faster. But it's summer here currently, so you'd think that it would not be so crazily different. I don't know. I just basically any spray paint, I'm waiting a week. Unless it's 2K spray paint, and then it's, 15 minutes. And it's crazy hard. These little screws adjust the position. You can center the tailstock appropriately and then lock it into position when it's centered. I tried to keep oiling as much as I could as I went along. I didn't want to miss a spot. Obviously, I didn't get the chance to machine the V-ways. It would have been something that would have been nice to do, but it's just not, it's not worth it for this type of lathe. Like, you can't go spend $500 on regrinding the ways just to have a lathe that can barely cut anything due to its hollow spindle. It just doesn't make sense, although would be cool to see. Maybe on the larger lathe restoration, if I ever have one. Which I don't, but I would love a full antique lathe to get to. It'd be a lot of fun. Now we're back to assembling parts of the cross slide. So the handle and all those things are fairly straightforward. If you notice, I forgot something here, but I fix it later. I won't tell you what it is, though. And I just keep oiling as much as I humanly can. My oil is the same as I always use, which is non-detergent 30 weight oil. Just because I don't know what the detergent will do to anything. In most cases, nothing. You just don't know, so you might as well just keep it as normal oil. And in its convenient antique oil can, it's very easy to apply. So I have no concerns about using that as much as I want. Getting the ball in here is key to my sight so that it stays in there and doesn't enter my eye socket and blind me forever. I would not be as good without any depth vision. It would make for possibly more interesting restoration videos, though. So I'm thinking about blinding one of my eyes. I lightly punched it over, and that seemed to honestly work well enough. So that's fine. These feet, I spent a little time flattening them on the diamond stone just because they had a lot of burrs all over them. I don't know if that matters or not. These weren't hardened either. They're just these two things and the cast iron clamp on the other end are all that hold the cross slide on. So basically all chattering will come from these types of little tiny things holding it on. I flattened these two. These really should be made of brass. It's kind of odd to see steel gibs or jibs on a cast iron cross slide. It seems fairly aggressive, but I guess it's cheaper, so that's why this was done at the time. And by the time, I mean 1948, which I believe this lathe is from. If someone, whoever bought this lathe, just wanted to spend twice as much, you could have had an insanely crazy, very nice lathe, but some people don't have that type of room. You get what you get. This was also, specifically this lathe, was actually given to me and was completely free by a viewer, so I have to thank him very much for that. And you'll see on the end of the video if we can get something working or not. I don't want to spoil it. There's the spacer, a very sneaky spacer. This helps control the kind of backlash, so to speak, in moving the cross slide. So these nuts, I've decided to just repair them and just bend them back where they need to be, and then flatten them out as much as possible. Only because I'm not really sure if remaking them out of anything else would be more detrimental to the cast iron than to the actual nut itself. So I'm just going to leave it as what was originally designed. And I just straightened it out in the vise, heated it up with my little propane torch, and then hammered it out on the little anvil just to flatten it out, since it was kind of convex for no reason, because it wants to be. Then just flattening any mistakes that I made while I did this intensely amazing forging process. It's very simple. I'm sure there are a million other ways I could have done this, but that's just how I thought to do it. Of course, when you hammer on the end of threads, you may have damaged them in some way, so I'm just going to run a die over both of these and just make sure that the threads are El Primo, because we don't want to have nuts that don't clamp down on anything. They slide fine, even with a little bit of oil. It's going to be fine. It's not going to get a crazy amount of movement in its life, so I'm not massively concerned. But there really isn't a lot of room to the left and the right of the nut. It's very long in one direction, so its clamping force might not be the most exquisite in the world. Now this little handle, I believe, was actually just aluminum. I probably could have shined it up even more, but I just kind of kept it as the same kind of dull as the rest of those zinc parts, which seemed to not get very shiny at all. I did try to shine one up on the buffer and didn't really do what I wanted it to do, so I just left them all as that kind of dull gray. It's a good contrast, I think, with the kind of shinier paint. Now, speaking about the paint for a second, I didn't do a clear coat this time, and I felt like that was the right way to go, because based on pictures online, originally it didn't look very, very shiny. I could have went with a clear gloss, a semi-gloss, but it might as well just go with the gloss that the paint itself had and just go heavy on the coats on the actual paint, the colored paint, that is. So that's what I chose to do this time. I think it worked out well. I might do that more often, since the semi-glosses that I seem to put on things are still too glossy and make things look too plasticky, and I don't like that look at all. Here's, I guess, the only kind of measurement indicator that we just applied with a nice brass accent, of course. And now it's time to tighten those things up, those weird feet that clamp on. I don't like that back and forth movement. It bothers me. this little wing nut is literally the whole thing that clamps this down, and obviously during vibration it could just unscrew slightly and then you'd have a bunch of vibration in the cross slide. So I don't like that. Also, I installed this washer here, this spacer, and that stopped a lot of the backlash moving back and forth. It's just not something I enjoy, so I'm glad that that helped. I'm rethreading the spindle here. It just looked a little chewed up, and you might as well clean those threads out. And then just polishing the actual spindle. Since there was a bunch of weird stuff on it, you just want to get a kind of nice, clean surface there. Since it's going to be running in the bushings, you want it to be nice and smooth. We took a measurement here, and it was pretty much right at half an inch. So we're going to aim for something just a few thousandths bigger than that, because when I press this in, it'll shrink just a little bit back into the casting, and that should bring the fit to very, very nice. And once tapped in there, it was fine. It tapped in just easy enough that I could hammer it. It was almost a case where I needed to push it in, because hammering on bushings, not ideal, obviously, but I use the softest hammer I can possibly find. These new bushings are just standard size bushings. They were not machined, and I just cut them to size and dealt with them that way. And that did clean up a lot of the movement, which was nice. I also, right here, forgot to put those brass washers above and below the gears in this planetary gear assembly. I'm not sure how much those are needed. I understand their purpose, but with new bronze bushings in there, I'm not sure if it's the end of the world. I do fix it later, though, because it would drive me nuts to see those not installed properly, because they were there for a reason. This whole assembly, I believe, was an option, like an extra cost option, when you would buy this lathe. And this allows you to slow down the spindle speed big time, I guess, for cutting larger diameters if needed, or something else, obviously. So it's neat that this has that option, but you know, it's still a tiny model maker's lathe. There's that adjustable bushing going in. It's such a neat design. I like it. And that's the nut that the more you tighten, the more it clamps down on the spindle. And that obviously turns me on. I haven't seen that before in this arrangement, so it's cool to see. And you can see the nice fit, like we're just fitting in here. So this is fantastically better than what it was before, and should hopefully give a nicer cut than, you know, what was originally capable coming right out of the box in 1948. Although, how nice of a finish do you need on a type of project like this? This is when I realized I forgot to put the V-belt in, because I'm a genius. I'm the voice of a generation of people that just seemingly forget to do these things. It's fine, I just took it all apart and put it all back together, no big deal. This plate here was weird. It kind of divides the headstock and the gearing. It's weird having that bottom section, the circular portion that is around that shaft, be able to move so unnecessarily freely, and to not have like a nice indexable bushing or something like that that holds that in place. It's just nothing. It's a very odd design to me, but what can you do? Now all these pins are tapered. You actually have to punch them out one way and punch them in one way. So if you happen to be restoring this lathe specifically, pay attention to that. Otherwise, you're going to have a very hard time removing or putting the pins back in. And as you can see, this brass screw helps clamp this down, and this would adjust the gearing position based on the types of gears you have attached to this assembly, which would then correlate to the type of threads you are trying to cut, since this does have that power feed lead screw. This is obviously very professionally done in terms of assembling gears, but I guess that's just how it wants to go on today. This is the gear changer going back on, and the main gear that transfers the power to everything else. They're still in fine condition. Ended up sandblasting deep inside there just to get all that crap out because it just wouldn't come out. It's driving me nuts. You can definitely see the comparison between the old and the new bushings. There's way less material on the old bushings, so it's nice to have that super snug and fantastic fit. Ideally, you would also fix the OD of the bushings to match the ID of the gears a little better, but the way these gears run, they're so loose anyways, I don't think it even matters in this case. This right here was an extra screw that I had lying around since initially that screw did not exist when I took it apart. I always keep every extra screw that I have or some replaced screw that I did for every restoration, and maybe it comes in handy. That one was probably from the antique shear that I did since I replaced the screws with brass ones. This is just insanely fun to do. This is a sheet of 22 gauge aluminum, and it's just the best sound of all time. I'm going to be using this sheet as much as I can to remake tags. This is the thickness that a lot of these aluminum or steel in some case, or brass labels are on these older machines. So it will be nice to have this sheet around. It was something like $4 or $5 when I picked it up. It was basically nothing. So it will come in handy. The actual sticker that needs to go on here is the threading chart, and it went inside of the gear housing. It lets you know which gear positions correlated with which types of threads that you are trying to cut. And there's a bunch of diagrams and a table with the teeth of the gears and how you want to set them all up. So it definitely comes in handy, and therefore they put it on the lathe at all times. I don't like that there's nothing on the other side. There's just holes in the casting. They could have maybe had a double-sided one or just put them on the outside. I don't know. That's just the way it is, I guess. What can you do? I am not the craftsman lathe designer in 1948. Although now if I was, I would do a better job, that's for sure. This decal's straight from vintagemachinery.org. They have a huge collection of vintage and antique decals for all of the major, in quotes, companies. Craftsman obviously is one of those, and they pretty much have every single decal ever for Craftsman tools, so you can snipe one off there if you need it, and then go to your local print shop to get a sticker made. Very easy to do. I do have some extra. If you need one, please contact me, because I think I have like 20 now. So the chuck is on. Look at its nice movement. Exquisite. My only fear at this point is the chuck true? And is it going to run nice and not wobble everywhere? We're going to find out, I guess. I'm grinding a flat on that because screw you, little tiny set screw. You're ruining my life. The tags are going back on. That one's literally fine, so I'm not going to mess with that at all. I have a new high-speed steel cutter in here. It's looking like we can actually do some work. First up, centering the tailstock with the center of the chuck. That's what these little side screws are for. And it's just fine. So that's good. And then you center the actual cutter to the tailstock there, and that should be fine. Also to the chuck, technically, would be more important one, but those two things should be similar at this point. It didn't say to use grease. There is a manual for this online from the 40s, and it says to use oil, so I guess I'm going to use oil. I'm not exactly sure why. Grease would kind of make more sense, but whatever. Here, I basically show you how centered I got it, which is fairly centered. You can kind of see the facing cut, but it wasn't set up properly. Here you can see me touch the power feed, and the screws just very slowly feeding this into the workpiece. And I'm taking the world's lightest cut of all time. Here you can still see the lantern post or the actual cutter moving back and forth. Like, it's still not the most rigid lathe, nor will I think it ever be in its current configuration. You could rig up some ways to lock down the cross slide more. I think this would be a serviceable lathe. And there are actually websites online that show you how to do that for this model, and I've linked those in the description if you happen to be working on something like this. It honestly didn't give too bad of a cut. I did go insanely slowly, and that is a very sharp new cutter, but it wasn't that bad. I thought it would be worse. I don't think it can handle steel. It's not gonna happen. It's gonna hurt if we try to do steel. So I'm just gonna leave it at brass for now. I might be selling this lathe or giving it away. I think it's nice to pass things on that have been given to me. So look out for that in the future. And otherwise, I thank you all for watching once again. See you in the next one. Later.